Hello, my name is Leenaars, and one of your professors asked me to tell you something about how we in Hanover do data extraction for systematic and systematized literature reviews. So this presentation will consist of a large part on data extraction. We will start with our normal workflow, which can follow two different procedures. Then I will show you some of the methodological work we did on data extraction, which comprises a comparison of data extraction platforms and how we extract data from graphs and what the precision of that actually is. There will be one slide with tips of what to really think of when you're extracting data, and there will be one slide with a recap and references. I assume you have seen all the other movie clips already, so all the other recorded lectures, and in those you've seen more examples, I will go more on the theory behind it. The main distinction between the two workflows that we use in Hanover is that we either use data extraction forms or that we extract directly to the data file. When I started doing systematic reviews, we always followed a workflow where data extraction was done directly to Excel, so directly to the data file that we used for subsequent analyses. However, for large reviews where you collaborate with multiple people and for reviews where you're really stringent on the quality, you want two independent reviewers to extract all data and to compare them before you start your analyses. And then Excel is not a handy option. Your optimum workflow will depend on two main factors. The first is the amount of data to be extracted, and that depends on the number of included papers for your review, and also on the amount and complexity of the data to be extracted for every included paper. The second factor that determines your optimum workflow is whether you will have one person extracting all the data with quality control afterwards, or whether you have multiple people sharing the workload and even independently extracting data from the same papers. The amount and complexity of the data to be extracted for every included paper depends on the type of review you're performing. And for a full systematic review and for most scoping reviews, you will have pretty detailed data extraction with multiple study characteristics of interest, risk of bias, and also outcome data. However, if you do a mapping review, you will extract data from more papers, but you will only extract one or few characteristics per included paper, and that means that for the data extraction you can actually go quite a bit faster, but you will have more papers to go through. So if you decide to extract directly to the data file, you can use any spreadsheet program that you're familiar with, but you're probably familiar with Microsoft Excel. If you are going to use a platform for independent data extraction by multiple people per reference, or for having a coordinated data extraction form for multiple people to work with, then the two free options are SRDR Plus and Serve. And there are two other really affordable options that you could consider that are Confidence and EPI, and all these four will be discussed on the next slide. An intermediate between the two options is Microsoft Access, that you will probably also have access to, where you can create your own data extraction form, which could be used by multiple people, which will result in a more homogeneous data set that will require less data cleaning after your extraction is finished. So before we started our first data extraction using a platform with multiple reviewers working on the same data extraction, we actually tested the platforms that we could afford. So that's the two free platforms and Confidence and EPI, which are quite affordable. There are really great options out there, and if your university would have a license to them, I definitely encourage you to explore those alternatives. But I can only tell you of our experiences with these four. So we tested them with a reference set for an ongoing review where we had to screen all the reference lists and came up with studies that were not retrieved by our searches. We imported those into EndNote and then split the file in roughly equal parts to test screening in the platforms and data extraction. And for today, I will focus on the data extraction results. So for the data extraction test, we did a fake extraction. We didn't extract real actual data, but we made it easy for ourselves to quickly do these tests. with irrelevant data that could easily be found in the included papers. We created the data extraction form, so that was the first thing to test. How easy is it to create a data extraction form? And then we extracted data of different types that you would normally come across in systematic literature reviews. So for free text, we had a standard format for the study identifier listed as free text. And free text, I think, is one of the most complicated types of data to extract homogeneously and to analyze afterwards, which is why we had it in our test. Now we had very simple numerical data, the number of words in the title and the number of references, with some missing data in case the reference lists were long and not numbered. And we had categorical data where we had checkboxes for distinguishing animal-human studies and studies including both animals and humans, and for the study design, which could either be disease control or treatment control. And after this extraction was completed, we also tested how we could export the results. This fake extraction was done by 2 independent reviewers, so we could also test the discrepancy resolution afterwards. And both reviewers recorded all their positive and negative experiences with the 4 platforms that we tested throughout the whole process. So the first tool we tested is Confidence. And Confidence was a very pleasant experience. It's very peaceful to the eyes and it's very intuitive to navigate in all the different phases that you can use it. The only 2 disadvantages that we had with this tool is that inter-rater reliability is only available for screening. So if you want to know how consistent your data extraction is, you would have to manually log that. It's not something allowed in the platform. And discrepancies can be solved by one screener, which can be very efficient, but it also allows for cheating. So you will have to consciously decide to work conscientiously and not cheat. The second tool we tested was Epi. Epi is a very useful tool, but it is way less intuitive to work with. So you will have more time spent on training up front in getting to know the tool and learning to work with it. And this may or may not be worthwhile for you. And we would suggest to use Epi for in-depth qualitative review where you are planning to do in-depth text analysis, because it has options for text analyses in the tool that are not available in any of the other tools. The third tool is SRDR+. And again, this was a very pleasant experience at the start. We thought it looked nice and it had very flexible data extraction forms that were easy to create. And it's a free tool, so that's also definitely an advantage with limited budgets for systematic reviews being available everywhere. However, the instructions for SRDR+ were really inadequate, and we could only batch import if we had a PubMed ID. And as you always use multiple databases for systematic literature reviews, not all of the references that you want to analyze will have a PubMed ID. So without the PubMed ID, you had to manually record the reference or enter the reference into the platform. And that was the reason that we did not select this tool, and that we would for the time only recommend it for reviews where you only do scoping of PubMed. The last tool we tested is Surf from the Kameradis group, and Surf has a pleasant layout and it's got good resources online, a good manual. It's very intuitive to work with, so you will get started quite easily. And for screening, it can work quite well, but it has some minor disadvantages compared to Rayon, for example. So I would personally always prefer Rayon for screening, because there you can work faster. And then for data extraction, Surf works well, but it's the data extraction form creation that is a bit challenging. So if you start creating your form, you have to get it right in one go. If you are at the 30th element of your data extraction form and you make a mistake, then it is not possible to correct that mistake. You will have to start a new project and start from scratch, which is why I personally do not select this tool to work with at the moment, because I'm probably too sloppy for that. When you're extracting numerical data, it will happen quite regularly that these data are only available in graphs. The authors made a nice picture and thought that was sufficient, so they do not have the numbers in the table or the text anywhere. Of course, we want to contact the authors then, because they have access to the actual numbers and they can give us a very precise estimate or the actual amount that we're interested in. But if the authors do not respond, then we can also get the data from the graph to include it at least in our systematic review and meta-analysis. There are digital rulers out there, and there are visual programs that you can use. And we are currently using GIMP. And then we import the picture into GIMP, and we can do pixel counting with the compass function. A tip for precision is to measure wherever possible tops of lines to work as precise as possible. It's more difficult to estimate the middle of a line because of the line thickness than the exact top where black and white meet. So you will work more reproducible if you measure the tops of lines. However, sometimes the symbols have different sizes, and then of course this doesn't work. It's fairly simple to get the amounts right, but you have to keep in mind that the axes might not start on 0 and that they might also be broken, so check that. In case that happens, then you have to move your measuring around and take a different part of the axis to get the amount per pixel right. So the data is, first the axes are measured and then the data are measured, and you have everything in pixels, and you have the axis also in the unit of interest. And then with a simple cross multiplication, you can reach the actual number. As we were curious to see how precise we can actually do this data extraction from graphs, we did a little experiment. And therefore, we took data from a preceding systematic review where the authors had responded to our queries for the actual data. So we had the actual data available. And then we had 6 PhD students extracting the data from the same graphs. And they extracted in total 36 concentrations with the corresponding errors from 28 figures in 22 different papers. For these data, we analyzed the differences between extractors, the differences between the original and the extracted data, and most important for us, the potential influence on meta-analyses. The consistency between different extractors is really good, and on the left we see the overall concordance correlation and the overall precision and accuracy for the 6 extractors, which have very high values for the outcome, so the concentration that they measured. And we say that the levels are a bit lower for the corresponding standard error, which makes sense because the outcome is value and the SEM will always be a smaller value, so smaller values are more difficult to measure. We see the same for the concordance correlation coefficients for the individual extractors compared to the original data. Again, the results are very good, very positive. This work can be done quite precisely, and for the outcome, of course, the results are better than for the smaller SEMs. So to analyze the potential effects of the errors in data extraction on meta-analyses, we did a meta-analysis where we compared the extracted with the original data, and we can see here that the differences are small. So overall, we do not expect a large change in effect size because of extracting data from graphs. Some general data extraction tips. I think the main tip is to adapt your data extraction to your review question. You can extract a lot of data, but the data that are relevant to your review question are the most important to extract. And with that, of course, you also extract the main study characteristics that can affect the outcome, because then you can incorporate those into your analyses, qualitative or quantitatively. For the reader, it's really nice if you harmonize the units. So the papers that you include may have concentrations reported in mg per mil, but also in millimolar. These are not directly comparable, but if you convert the one that you have least of into the one that you have most of, then it's a lot easier for your readers to understand the overall implications. If you have different outcomes for the same phenomenon, you can still run a meta-analysis. And I always state this as comparing apples and oranges, which is perfectly fine if you're interested in fruit. So if, for example, you're interested in intelligence, you might have specific tests for that, and you might have academic grades. So this is a human example. And the scales will vary, so you cannot do a direct comparison of these units, but you can use a standardized mean difference, which is based on the difference between groups expressed in standard deviations. And then on those values, you can actually run a meta-analysis. Another important thing to keep in mind in data extraction is when you prepare a meta-analysis that you should not mix up the standard deviation with the standard error of the mean. Both these values are informative, but you need to choose one and convert all the others into that one to have a homogeneous data set. If you have values for the standard deviation and for the SEM all mixed through each other, then the weighting in your meta-analysis will not be fair. And that is something to prevent. And if it's your first review, then I would like to tell you upfront to expect missing information. It's very sad, but reporting of experimental detail is generally poor and you will have missing data. Also for the outcome measures, which are sometimes so hidden in the paper that you have to include the paper because it meets your inclusion criteria, but you cannot include it into your analyses. Also for the risk of bias, you will get a lot of unclear just because the details to evaluate the risk of bias are lacking. So while I would advise against extracting data that require a lot of time to get it right and do not add that much to the information that you want to analyze, there are a few non-standard data that I would like you to consider. One of those is the country of ethics approval. If you extract that, it's relatively easy. It's easy to find. It won't take you too much time. And it will allow you to create world maps with an overview of where the studies you included in your review have been published. And this actually looks quite nice, and it's very easy visual that describes the sample of what work is done where. Also, if you can keep the full abstract in your data set, I think you should, because with that you can quite easily create word clouds and text frequency correlations, which are not yet common, but they can be very, interesting. So a brief recap of this little presentation so far. I've shown you that we have two different workflows for data extraction. The first one is directly extract to a spreadsheet. And this is very efficient if you have one person extracting and the second one doing the quality control offline afterwards. The second workflow is by using a tool. And if you have multiple team members working together at the same time, this is definitely preferable. If you use a tool, choose the appropriate one for your purposes. It can save you a lot of time. And if you are extracting data from graphs, as long as you work precise, you shouldn't worry too much about the quality of your data being affected. So if there are any questions, feel free to email me. I'll try to respond as best as I can. I'm sorry for not being able to do that in Portuguese. I can do French, English, Dutch, and German. Probably English is easiest. And if you're interested in reading more, the review types is a paper that we published and the DOI is on the slide. Same goes for the data extraction where we compared different extractors from graphs. And the comparison of the different tools for data extraction is actually still in progress, so I cannot give you a reference of that yet, but I hope that you enjoyed the sneak preview. And with that, I wish you good luck with the remainder of the course and with reviewing.